Hey everybody, thought I'd take some time to do another quick code tutorial. Now, typically in the past, I've always focused on Ember and Elixir and Phoenix. That's just not where my experience has been the past few years. I've spent the last about 3 years really working within the React domain, especially React Native, but I came into React when hooks were first being introduced. I didn't really get a lot of time with class components, but coming from things like Vue and Ember, I was very used to working in classes and working with normal JavaScript objects. So functional components, they were a little confusing to me, especially useState and how we manage stateful logic. So that's what I wanted to dive into today, because I feel like I run into a lot of gotchas with useState, and I feel like there are a lot of great tutorials out there, but not a lot of them do a ton of good deep dives into how useState works, and also useReducer, which I wanted to cover in this video. So thought I'd go through a quick example of when to use useState, some of the edge cases around it, what it actually does for us, and how you can avoid some of those pitfalls. All right, so let's actually hop into some code here. So I'm literally just spinning up a brand new Create React project here. I didn't bother recording that since it's pretty straightforward, but we're just going to hop into the default template here, and let's just start this app. Okay, so here is our default Create React starting app, and we're just going to go in and delete some of this boilerplate here. So if you're not familiar with sort of the structure of React and how the components work, this video might be a little overkill for you since we're diving deeper into a different concept. But basically we have one component to start with, that's our app.js component, and I'm literally just going to delete everything here except for this div, and I'm going to go ahead and just create a new component. We're going to call it clickything.js. So we're going to import React from React, and we're going to create our component, clickything, and that's just a functional component. We're not going to deal with any props right now, and we're just going to export default clickything. So now if I come here, I can import clickything. VS Code will find that for me. So now if I come here, I have a blank page. So let's go into our clickything. So return. So functional components, they're functions that run and they return JSX at the end. So we're just going to return some JSX here, and let's maybe just add an H1. Call it clickything, and then we'll go back to our browser just to make sure that it actually shows up, and there it is, clickything. Okay, great. So how do we use useState? The whole concept of functional components is that they're pure functions. You can just call them and they just run. So how do you deal with stateful logic? So logic that needs to be retained between these functions runs, because you can't really have independent components if they sort of always have to keep passing values to one another. So useState is a way to sort of get around that. So the first thing we're going to do is just import useState from React. So useState is a hook. It's a function that gets run every time this function gets called. And this function gets called every time we have to render or update our component. So we are going to create two variables here that come from useState. We're going to call it count and setCount, and that equals useState. So useState again is a function that returns something. It returns an array. So if you're not familiar with this syntax, this is how you would destructure an array. So really you could say const count state equals that, and then const count equals count state at index 0, right? This is just the shorthand way of doing that. So if we assign our variables within square brackets here, we're saying this value is going to be an array. This is what I want to use as the variable for the first thing in that array. This is what I want to use as this variable for the second thing in that array. So we have a variable called count, and now I want to maybe just display that on our page. H2 will say the count is count. So if we go back here, it says the count is nothing because it doesn't have a value right now. So one thing that we can do with useState is pass a default value to it. So this is its starting stateful value. So now if we go back, it'll say the count is 0. So what we want to do is we want to add a button that just increases the count. So button, we'll just call it add 1. So a button has an on-click event, and when you click it, it will call a function. In this case, we're going to call setCount, and we're just going to do count plus 1. So the first thing that the useState array returns is the actual stateful variable. The second thing that it returns is a function that we can call to update that variable. So let's save that, and now if I click this, it's just going to increase, and it's going to keep going up to infinity. So there are a few things to sort of watch out for here already. Let's start by moving this logic to a separate function. So we'll call it function, we'll just call it add1, and we'll do this. We'll do setCount, count plus 1. So this should do the same exact thing that this down here is doing. We're just not writing it inline anymore. And the other thing I'm going to do is console log count. So we're going to call setCount, which should update this, right? And then I want to log to see what that value is right after. So let's just open our terminal here. Let's refresh. We're going to click 1 once. We're going to get the number 1. However, what we got here was 0. And this is, I'd say, the first caveat with setState versus class components, where we're dealing with objects where you could say like this.count equals something. We are not updating this value right now. What we're saying is the next time you call this function, this will be the value of count. So we did not actually mutate this variable right here. Instead, we say, okay, keep doing what you're doing, and then we're going to force a new re-render. So every state set function, so the function that is returned from useState, will force a re-render of our component. So it'll force it to run through all of this stuff again. So we call setCount here. We haven't updated count. We can continue to do lots of logic after this, right? It won't re-render until it has finished that logic, and now it'll come through and it will have updated this value. So if I click this button again, now I get the value from last time, right? But we don't actually update this until everything has re-rendered. So as I was saying, every time we call one of these functions, it forces a re-render. So it will ultimately return JSX again. So I want to actually track that. So right here, I'm just going to add a console log. We'll say we're re-rendering. Now console log just returns a null value by default, so this is actually just a shorthand way of me adding a console log every time we render our JSX. So we'll say return console log, which will return null, or render the JSX. So it'll render the JSX, but it will also call our console log here. So let's go back. We'll just refresh to set our count. So we get 1 re-rendering. Technically that's not re-rendering, that's just the initial render. And then if I click add 1, we'll render again, and again, and again, and again, and again, and again, because we're updating this value. So every time we call this, we get a re-render. Now let's say we want to cap this value. Let's say I don't want the count to ever go above 3, but I still want to call this value here for some reason. So we'll say we'll say const new count equals, if count is greater than or equal to 3, we will return 3, else we'll return count plus 1, and then we'll pass new count here to this function. So again, we're still always calling this function. However, we are going to cap at 3 here. This is some if-else logic. And now let's see what happens here. So we have the count is 0. We click add 1. We get our little re-rendering down here. That's what we expected. 2, we get 3. But you see, if I keep clicking this, it actually doesn't keep re-rendering. And that's because set state will actually compare the previous value to the value you're trying to set it to. And if it's the same, it will not re-render. So in this case, it knew it was 3 before, and it knows you want 3 this time. So it actually didn't trigger this. It said, okay, even though you're calling this, I don't actually need to re-render any of this content. So this is a case where set count is actually pretty clever, and you don't necessarily have to write a lot of logic to like conditionally call this. If you know that the case is just going to have the same value again, it actually won't go through this whole life cycle if it's setting it to the same value. Now, I do want to make a note here, talking a lot about re-renders, and typically as a developer, you don't really want to worry about how many re-renders you have. That's an optimization that's usually overkill for most people. I'm only calling it out just so that you can kind of understand what it is that useState does. I think it's good to know what calling that set method from useState actually does for us. But if you're worried about too many re-renders, you might just be optimizing for the wrong thing, or you might not even want to use useState at all if that's a big concern for you. And I should also call out that even though we might be forcing a re-render from our functional component, React is still doing a lot of clever things sort of behind the scenes to compare the virtual DOM to the real DOM and knowing whether or not to update. So even though we might be forcing a re-render, the actual browser might not be rehydrating for us. So it is important to remember that even though we're triggering a function again, React is going to do some clever stuff for us and sort of optimize for us behind the scenes so that we don't actually have to worry about it. So we have a pretty simple use case right here. We're just increasing a number. Let's say we wanted to still deal with a number, but it was dependent on some other function to sort of like do that calculation. So let's say we had some outside function here. We'll call it start plus 1. So it's going to take a number and it's just going to return that number plus 1. So now, we're going to pass a function to our useState. So rather than passing a value now, we're going to pass our function. So we're going to say start plus 1. So this will give us a value of 1 because we're going to pass it 0 and we're going to add 1 to it. And for now, let's just get rid of this logic. We'll just do count plus 1 again. Great, so now we're re-rendering. We started at 1, we're going to add 1, started at 2, and that all makes sense, right? We essentially just passed it a function, right? A value from a function, and then it went through and it sort of added 1 to it. Now the confusing thing here is you would think that this would only evaluate this value once, right? The very first time, and then not again, because now it's saying, okay, I don't need this default value anymore. I have a stateful count. On my re-renders, I'm just going to use that. So let's actually add a console log here. We'll say start plus 1 has been called. And I just want to see how often that function is called. So we get start plus 1 has been called, right? It should be the very first thing that appears. And if I add 1 to it, I actually see it gets called again and again and again. So even though we're not doing anything with the value there, it is constantly getting called for us. And that's because we're essentially assigning it to a variable, right? You could also write this as const foo equals start plus 1, 0, and then pass it to foo, and pass foo to useState, right? It's always going to evaluate this, even if it doesn't use it here. However, you can still sort of get away with it, get around this, by passing either an anonymous function or a function, a non-invoking function. So we could do it like this. We could pass an anonymous function, start plus 1, 0. And now, if we go here, so we get it, start plus 1 has been called once, but now we actually never get it again. So we only run that function once on the very first render. This might look like confusing syntax, kind of is, to write it all in line there, but essentially rather than this, which is the result of this function being called, we pass a function as a parameter, and useState will then call it the very first time that it runs. If you're an old school JavaScript person, you could also write it like this, bind this 0, same exact thing before we had arrow functions, and that should give me the same exact result. this function is only being called once. Now this might not seem important, but let's say this was a really complex algorithm that was doing some heavy calculations and you didn't want to run it every render. That's how you would sort of get around it. Cool. So again, we're dealing with some pretty simple examples here, but let's actually get into a more complex example. Let's say we have a person. So person and set person, and we'll give it some default values here. So person is going to be an object, and they're going to have a name, which can be Scott, and an occupation, which can be developer. And let's render the stuff on our page here. So if we go down here, we'll say, we'll just say name, person.name, and we'll say job person.occupation. So just make sure that this is showing up. So we have name Scott, job developer. So let's write another function. We'll call it change to Bob. So I'm going to call set person, and I'm going to say their name is Bob and their occupation is a builder. Oops. So I'm going to add another button down here, and we're just going to call it change to Bob. Change to Bob. We're going to refresh. We're going to click this, and look, it updated our stateful variable here to be Bob. So what happens if I click this again, though? Well, we didn't get a visual change here, but it's still calling re-rendering over and over again. And the reason for this is that you cannot compare two objects the way you can compare two numbers or two strings. So when we called set count here, right, and if the new count was 3 and the old count was 3, then it didn't re-render anything. However, when we call set person here, even though the name is Bob and the occupation is builder, both before and after, it still forces a re-render because it is technically a brand new object. You can kind of play with this in the terminal if you want. Like let's say 3 equals 3, right? This is what set state does. It compares these two values. It says, all right, that's true, so I'm not going to re-render. But let's say its name is Bob, one object, compared to name is Bob, same exact object. That's false though, because they are technically two different objects in memory, even though they happen to have the same exact values. Now, what happens though if we just returned person again, right? So we're going to take this object and we're literally just going to pass it there. So in this case, we shouldn't see a change here, and we actually don't see a re-render here because now we're actually literally taking the same exact object as before and passing it to our set function, and it should return true when it does that comparison for us. So set state is really tricky when you're dealing with objects. You're almost always going to get a re-render there. The set function that's returned by useState will accept a value and assign it to this value. It can also accept a function that returns a value, and then it will assign it to that value. And that sounds really confusing, but let's say we wrote it like this. And then I returned an object with name Bob, and again we'll do occupation is builder. So let's save that. Let's do this refresh. And now if I click this, we get the same result as before. We're still going to get the re-renders because, again, it's always a new object. So why would you do it this way rather than just as a default value? Well, this anonymous function actually gets one parameter, which is the old value. So let's console log old value so we can take a look at it. So we're going to change Scott to Bob, but we get the old value passed to us first. So if you needed to write some sort of conditional logic based off of the previous state, in like our account example, if we didn't want it to exceed 3, we could actually look at the old value first, right, and then either return early if it's not the same value, or keep going if it's different. this is where you would sort of write that logic. So that's why those functions come in handy, because now we can actually call setState conditionally within the parameters here, but maybe the button doesn't have to worry about whether it needs to do that. It just calls one function, this function, and that evaluates whether or not it wants to do all of this logic here. So if you do have a lot of logic like this, where the new value that you want to return is dependent on the old value or has forking logic based on the old value, that's when you might want to get into useReducer instead of useState. So let's actually import useReducer. And I always put it first because I like to go in alphabetical order here. It really doesn't matter. So let's create a new stateful variable, and we're going to call it new person. And we're going to call it useReducer. So useReducer does have a very, very different syntax. Like useState, it does return two things from an array. One is the stateful value, and then the second is what's called a dispatch value. And if you're familiar with Redux, the concept of dispatch might be really familiar. We're going to dispatch something up the chain, and it's going to take care of updating our value for us. And we can call this whatever we want. So I'm going to call this update or dispatch person. What does reducer accept as parameters to the function? So again, useState can either accept one argument, right, which is the default value, or it can accept a function that it will call, and that returns its default value. In this case, useReducer, its first parameter, it has to be a function. This is the function that will get called every time we dispatch an event. So I'm going to write a new function out here called personReducer. We'll leave it blank for right now. So the first argument, again, is personReducer. So that's the reducer function that's going to get called. And then the second thing is the default value, or what are called the initial arguments. You can see the linting right here. So let's say this person has a name of Lisa and occupation is scientist. And let's update this stuff here. We'll deal with new person instead of person. Save this and look here. If I refresh, we have Lisa and we have job is scientist. So we're very, very similar so far. But now we actually want to update that value. We want to dispatch a new value to our stateful new person here. So how do we do that? Well, we'll write it as a new function. We'll call function update reducer variable. Not a good function name, but we'll live with it for now. And we're going to call dispatch person. And we're going to pass that an object. It always expects an object here. Well, actually, it doesn't always expect an object, but we're going to deal with an object. And we're going to say the name is now Diane, right? We're going to dispatch this. So now let's bind this to this function, and we'll just call it change Lisa for now. So dispatching to our reducer is going to call this function. So let's just make sure it actually gets called. Let's refresh, and if I click change to Lisa, it does get called, but we get some errors here because we didn't actually return a value yet. So I did want to jump in a little more detail into what the reducer function does. So much like Redux reducers, it accepts two arguments. It accepts the state, which is the current state. It also accepts an action, which is the thing that we're trying to do, which includes the data that we're sending along. So this is usually when you would have a lot of different logic, because a reducer is designed to deal with the previous state and then take action based off of that previous state. Again, we did this with setState. It just was a little more verbose, whereas reducers, like, they're designed to deal with this logic. So if you have a lot of forking logic, that's when reducers can really make a lot more sense. Let's just return. So state here is just new person. It's the previous value of new person. So we're going to say return state. We're going to destructure state. So whatever variables are there, we're going to assign to this object here, but we're going to change the name to be action.name. And in fact, let's just call console log state in action here so we can see this. So we refresh, we have name Lisa, job scientist. We're going to change. So we got the name change here. We saw re-render. We got the previous state, which was name Lisa, occupation scientist, and we got this, the action, which is just the name. So what exactly is action? It looks like it just passes whatever we send to our dispatch here. And yeah, that's pretty much it. It's very similar to a set function that we get from useState. It's up to you to sort of make this more dynamic and leverage some of the niceties that come with a reducer function. So the typical pattern that you would see would be something like this. Type name change, or I think a lot of people usually write it in caps, name change. So then when we come here, we would say like, if, oops, lowercase, if action dot type equals name change, then we'll do this. Otherwise, we'll just return state. Let's write maybe another function here that's update reducer job. We'll call this type job change. And we'll say occupation is president. Update reducer, change job. So let's go back here. So now if I go to change Lisa, we change it to Diane. We saw our re-render. If I change job here, so I called change job, we can see those values here, and it ran through this function. However, it didn't have any if conditions to hit here, so it just returned the state. Now you might be wondering, why did this trigger a re-render? Well, it's going to do that at least once, but every time thereafter it won't. So on that first evaluation it will, but again, because we're returning the same object here, it's not going to do that. But the idea being that you would write another condition based off of job change, and then you would compare it to the previous state. So if you have a lot of different like forking logic based off of the previous state, or if this function just has to be really big, I'd say this is when useReducer makes a lot more sense than useState. But a really important thing to note here is that there is nothing that useState can do that useReducer can't do, and vice versa. So that's a big question a lot of people have. When do I use useReducer versus useState? It is really up to you. It is your choice. There's no performance benefit. They both do deep re-renders anytime the state changes. It compares the previous value to the new value and determines whether or not it wants to re-render your component for you. And it allows you to do stuff based on the old value. If you want to, pass a function to set person, it allows you to set default values right away. Really, it's just preference. I think the tip most people say is, if you're going to write a lot of logic in your set function, use useReducer, because it's designed to do that. It makes the assumption that you're always going to call a function and handle some logic before you set the new state, whereas useState is easier if you don't have a lot of forking logic. They can both work with objects, they can both work with basic values, and it's really just up to you. If useState just makes a lot more sense logically to you, then just keep using it. So thanks for watching this far and going through those examples with me. Hopefully you have a better understanding of how useState and useRef work, and know that you can really use either one for whatever you're working with. It's just about what sort of makes the most sense to you and the amount of code that you want to write. There is one more hook to get into if you want to store stateful values and not force re-renders, which is useRef. And I'm actually going to talk about that in another video, because useRef is a huge can of worms. There's so much to it. It's really powerful, but it is very different than useState, and I think it certainly deserves its own topic. Another thing I can link to is a great blog post by Kent C. Dodds about when to use useState versus useReducer, which, much like I covered in this video, you can kind of use either one. But he gives a really good example of writing an undo and redo feature that I think makes the differences much more clear. If you have any questions, just leave a comment below, or you can hit me up on my email, which is in my bio. Thanks for watching.